Welcome to DESMA, welcome to episode 3 of our small mini-series regarding energy consumption reduction, regarding the reduction of CO2 emissions. Today we are talking technical measures. And when talking technical measures, we like to introduce some measures to you which are currently under development, which are also, well, they are logic in a way. So they must not necessarily be a product of DESMA, but some of them will be a product of DESMA. But we like to give you some ideas, some inputs, some things to tackle maybe also on your own, but also some things that we are working on here at DESMA. The first thing is, well, easy. It's a no-brainer, we would say. It's isolation. The more you reduce temperature losses connected to material circuits, for example, if you have a preheated PU system flowing through the pipes and hoses, and this is not isolated, this heat directly goes into your ground. It's lovely because your factory will always be nice and heated, but, well, you're paying a huge price for this. And by using and by applying isolation, you're reducing the heat losses connected to surfaces which are not isolated. So, for example, the pipings, the RGE, the material tanks, the mold and the mold tempering plates, there's chances either to reduce the heat used or to isolate those items in order to reduce the overall energy consumption. And by the reduction of temperature losses, you are also reducing the electrical energy needed for the tempering process, which we have explained in the first series, is done by indirect heating. So it's a huge leverage. The second point we like to put an emphasis on is something that we in Central Europe are currently learning from, well, a shift of how to use, where to get energy from. Heat pumps are used in houses, they are used in factories, they are used in stores, and they are used to, well, produce heat by electrical energy. And there's different coefficients. For example, this example we are drafting here has a heat pump incorporated that has a coefficient of 4. And by using 1 kilowatt hour of electrical energy, you are creating 4 kilowatt hours of heat power. And this is a huge, huge factor. And if this one is installed in a DESMA machine instead of the formerly or currently used TEE, well, the efficiency is increased, the energy consumption is reduced, and by this also costs are reduced. Of course, the heat pump is not for free, but a heat pump can be an option for your future tempering of your DESMA machine. The second point is, well, in general, external heat sources. There is solar thermal energy, there is waste heat from other processes, and both of this can be used to, well, heat, to temper your DESMA machine instead of using a TEE or a standalone TEE. So if you have a photovoltaic system on your factory's roof, if you have some other processes which cause heat as a waste product, why not connect this to a DESMA machine? And by using a so-called hydraulic box, you see a small picture here, you are using this heat in your DESMA system and you are, well, minimalizing or even, well, completely erasing an external own DESMA heat source. However, what we have to say, what we like to say is that also these external heat sources can cause electrical consumption and they can also result in CO2 emissions being brought in the ambience. However, the TEE can be replaced, supported, and in its energy consumption can be reduced by using also external heat sources. One thing that is, well, known to most of you, but it's also existing, is electrical roughing. The older roughing head is using a pneumatic motor. This is causing pneumatics, and pneumatics are used or created by using electrical energy. And you're losing this energy in a huge sense. If you're using an electrical motor, you have, of course, electrical energy consumed, but this is directly brought into the process. And with the introduction of our roughing head NX, we said that the energy consumption is reduced by 75%. And this is still true. So the electrical roughing is strongly reducing roughing applications in their energy consumption. and thus a huge recommendation from our end. Well, we are coming to an end of our series. We are coming to an end of some small tips and tricks on how to reduce energy consumption, how to reduce costs connected to this, and how to also reduce your CO2 footprint. And also here and today, we like to give you an overview of what Desma is offering as of today. We have every Desma machine coming in April and later equipped with hard and software to measure the machine's energy consumption resulting from pneumatics and also electrical. And this is called energy footprint, and it's part of your Descan visualization screen. So this is a standalone, this is a pre-configured visualization screen, and this is used to just give you an overview. If you like to work with this data, if you like to analyze this data, there is two different ways. The first one we already introduced. It's Easy Exchange. It's an interface to exchange the machine's data, and this also includes energy consumption data, for example, with third-party software. And this data interface is available for quotation right now, and it will be delivered as soon as possible, but it will be something that is slightly dedicated to your machine and slightly dedicated to your third-party software. So its customizing might need some days and weeks, but we are glad to consult you on this. We are glad to offer you here. And what is coming soon? That MyDesma is being further and broader introduced into the market. MyDesma is then offering an own software tool. I wouldn't say software system, a software tool that is used to analyze your machine's data when it comes to energy consumption resulting from pneumatics and electrics. So either you're good to go with the visualization screen, which is part of Descan, or you say, I like to use this data in my own software infrastructure, or you say, I like to use the data, but I don't have the according software infrastructure, so I like to go with MyDesma. These are three options that we like to equip you with, and we like to offer to you in order to get further in reducing energy consumption and costs connected to this energy consumption. Thank you very much for your attention. Hope to see you very soon.